Excellent. So let's let me share my screen. So inv norm. Okay, so the area to the left, 0.03. Oops, I didn't mean that. 0.03, and then 0, and then 1, and the left, yes. I always keep the left because I'm used to the older calculators, but you can use the other ones when you feel free to do that. Okay, so it's negative 1.88. Because we know, let me stop sharing for a second. We know what happens with z, right? So this is 0, this is negative 1, negative 2, negative 3. And this is it. Yeah, it can go on forever with very, very tiny, and it does. But this is it. 0 in the middle, negative 1, 1, negative 2, 2, negative 3, 3. So negative 1.88. So let's see how they want the answer. How do they want the answer? Round to 2 decimal places as needed. So it has to be negative. Where's my negative? Negative 1.88. Yes. Yes, z-scores at the area under the standard normal curve. Oh, they consider it to the right. They consider it to the right, not to the left. Okay, fine. So keep that in mind. So they want the area. Oops, I didn't mean to do that. They want the area to the left. No problem. That's what I said. In some books, is different. So if this is the area to the right, then we have 97 then. Because if I use left, then I have to write 97. So let me create this first. So 1.88, obviously. So they say that this, they don't consider it to the left, they consider it to the right. Every book is different. So now this is 0.03, and this is 0.97. So I used the left with inv norm. Area to the left, 0.97 and 0 and 1, and this is of course 188.
Is there a way to do this in StatCrunch?
The inv norm, let's take a look.
I have the directions for that in StatCrunch.
Yeah. So hold on just one second. Let me finish up this so it's positive. Okay. So just keep that in mind for the problems in this section. So let's go to, okay, the next question. So let me go to, where is my book? Okay. And I want to menu, I want to StatCrunch and StatCrunch. So that should be in normal, and it should give 0, 1.
Yeah, that's it, and then you just put the percentage in.
Yeah. So the percentage was 0.97. See, they are using left, and this is the correct use. It's the left. Okay, it's not the book invented something else, right? But that's what I said. Every book is different, but normally the area should be to the left, not the area. Z 0.03, it should not be to the right. It should be to the left. Even StatCrunch uses to the left.
So you just go to the normal calculator?
Yeah. Not normal calculator, normal random variable. Yes, but it's a calculator. Yes, calculators. Yes, calculations basically should have been, and this is for the normal random variable. Since it's standard, I have 0 and 1, So then you read 1.88 as we determined. But careful, because StatCrunch uses area to the left and the book says that it's area to the right. It's confusing. But thank you so much for bringing this to class. Thank you. That was great. Anything else?
Can we go over question 9?
Yes. If I find the book now. Where is my book? Oh, I know. The book disappeared because I'm in StatCrunch, right? Of course. Of course. The book went away. That's what it is. See this now, I knew the difference between 1 and 9. A study found that the mean amount of time car spent in drive is this. So I always take notes immediately. So the mean, so this is probably normal. 131.8. Assuming the relative times are normally distributed with a standard deviation of 34, is everything in seconds? Careful, yes, all these seconds. It completes parts A through D below. Okay. So what is the probability that randomly selected car will get through the restaurant's drive-through in less than 71 seconds? So is there any problem with this? Did you, because this we did in class together. Any problem?
I just kind of wanted to go over it again.
So this is the normal distribution. So with a calculator, if you want, second and distributions, and you go to normal CDF. So the probability for x to be less than 71, we have to start. So let me stop sharing for a second. So it was less than 71, correct? Let me go back. Yeah, good. So what happens here is when we, obviously the mean is 131.8. So 71 is somewhere here. So we're interested in determining this area. So the way we enter the area, of course you can use StatCrunch, but this is between negative infinity and infinity. Okay, and the negative infinity is entered with a negative E99 in the calculator, and positive infinity is entered with E99 in the graphing calculator. So I'll show you how to do that if you're using a calculator. Here it is. So see, it's okay. It's okay if you just write this. So it's right here. E is right here. So negative. Oh, no. So second and distributions and normal CDF, cumulative density function. So you can enter it as negative EE 99. That's good enough. And the upper is 71. So the area is between negative infinity and 71 with a mean of, what was the mean? 131.8. And the standard deviation of 34. And you press enter, and that's it. And this is it. So the probability or percentage is for this situation, for p less than 71, is 0.03687. And I'll copy what they want me to. Now, if you do this in StatCrunch, if I go to StatCrunch, it will ruin my. I have to go back to the book.
I think you can get to StatCrunch through Get More Help, I think.
Say that again.
The Get More Help button, I think it has a StatCrunch button in there.
Oh, maybe. Okay. So what is the probability? Round to 4 decimal places. 0.0369. 0369. Yes. What is right? The randomly selected car will spend more than. So you know how to do the more? The left one will be 184 to infinity. All the same thing. If it's in between, it's easier, right? So for greater than, you will enter the lower, which is 181 or whatever it was. The upper, in this case, the upper will be EE99. And let's see what happens. If I want to find the area or the percentage between negative infinity and infinity, of course, that's not the question, but I'm asking, what will I get when I press enter?
1.
Of course. Why 1? Because it's the entire area under the curve. It has to be 1. So as we expected, between negative infinity and infinity. Is this okay?
Yep. Thank you.
Thank you. Very good. Anything else? I'd like us to at least finish up 7.3 today, but I can move on before I answer anything else. Anything else? Anything else?
I'm good to move on.
Very good. So this is 7.3, assessing normality. Assessing normality. So we go on a path. So this is a life habit. We embark on a path, and we should always ask, am I on the right path? Maybe I can do better, right? Maybe ask some people, etc., etc. The same thing with assessing normality. So like we did with a residual plot. Remember, we said, okay, let's look at the residual plot for linear regression and see if a linear regression process model works for the data. Yeah, we got the correlation coefficient to be 0.9. Oh, awesome. But when we plotted the residual plots, we said, oops, we can use the linear regression. For this sample, may work, but I can draw conclusions because this model is not applicable. The same thing with assessing normality. We have a method of checking whether, okay, we say, I think it's normal. We all want everything to be normal, right? But when we assess normality, we realize that, oh, oops, I'm using a model that is not appropriate for the data I have, or for the random variable I have, or for the population I have that I'm studying. So the same thing, we have to assess normality. And we have a way called the probability plot. So we're going to look at the data set. Here we have the data, whatever, time, weight, height, whatever we are assessing. And here the z-score for each entry. If after we plot this, we get something like a line, if the probability plot is a line or very close to a line, something like this, then we will say yes to normality. Go ahead, use the normal distribution procedure or model for what you're doing. You're okay. But if when I plot what it's called the probability plot, if I get something like this, not a line, then I will say no, do not use normal distribution or normal procedure or normal protocol. It's not normal. Once I determine for the z-score for each entry, and I graphed here data and here z, the z-scores, and I have something like this, no, find another model. Or maybe apply some transformations to what you have. That's also a possibility. But do not use the normal random variable. Okay, I would like us, we still have, I hope you still have in StatCrunch Where is my StatCrunch now? I still hope that you have and you did not delete the data set. We have our data. And let's look at, we had a lot of things here. So bank rates. So let's see if the bank rates are normally distributed. So let's create a normal probability plot. So let's go to graphs, and it's right here, the QQ. I want the rate to be the variable that I'm not going to study the institution, right? And please make sure that you click on normal quantiles or normal probability on the y-axis. And let's take a look. And then draw a conclusion if I could possibly use the normal distribution or the normal model for this. So look at what happens here. Look at the graph. Would you use based on, yes, you can argue, wait a minute, you only have 6 or 7 entries. You can make a decision based on that, and I will have to absolutely agree. You can't. But let's assume that this is what we have. Would you use the normal distribution to analyze the data if that's the graph of the probability plot?
No.
No. No. Okay. So let's analyze different situations. So you're saying that I could go to the book by pressing something?
So I think she was saying that there's a get help thing on the questions, and there's a link to StatCrunch when you click it.
No, I wanted to go back to the not to the book, but to the assignments. Where am I? I'm here. So now let's look.